My talk mainly will focus on about process engineering to achieve multi-scale carbon neutrality and simultaneous. So today I will present some innovative and novel method and model what we have developed to achieve carbon neutral production and also manufacturing. Firstly, I would like to I can use the mouse. Thank you. I'd like to present the typical work what we have done, especially some model we have developed to help achieve the carbon neutral manufacturing and also production process. The first aspect is about system thinking to promote simple and carbon neutral production and also manufacturing. We have developed various models for carbon neutral oriented or sustainability oriented assessment and also decision making. For instance, if there are different processes for manufacturing or for production, so we can help the stakeholders and decision makers to determine which is the best one. Then the second aspect about carbon neutral oriented design and optimization, and for especially for some new emerging process, we can use the model to help the stakeholder and decision making stakeholder and decision makers to determine the carbon neutral process. Then for the second aspect, we have developed some innovative process that can convert waste into high value added product. Especially for instance, we can turn waste, including carbon dioxide, into products in an environmental friendly, cost effective way with high social acceptability. Okay, I mentioned at the beginning of my talk about system thinking. So what is system thinking? I'd like to share a well-known set of Chinese, an ancient Chinese philosopher, Zhuangzi. He have said, okay, in 普通话，天地与我并生，而万物与我为一。Luckily, I also see the translation in an English book, okay, and UK scholar have translated into heaven and earth live together with me. The married saints and I are one. So I would like to ask you, ask some of you, what do you think heaven and the earth here represent? And also he said, me, what does me in this sentence represent? The mirrored saints and I are one. Actually here, heaven and the earth represent the nature. Me represent human activity. Everything, including the production and also manufacturing process. So he taught us what should we do to achieve the so-called sustainability or carbon neutrality transition. So we should recognize nature, industrial process, especially some manufacturing and production process, and human as a whole to study. So in our work, we have developed some innovative model to recognize economy, environmental, and society as a whole. In order to achieve carbon neutrality, especially how we can lower or reduce the emission of carbon dioxide, we need to consider the interaction between among human, nature, and industrial process for manufacturing, for production. So we have developed a model to consider multiple objectives, including economic, environmental, social, political, and technical objectives. So why we need to consider so many objectives to consider the multi-dimensional objective? I can give you an example. For instance, there's a process for manufacturing. If we would like to reduce the carbon dioxide, we can first consider how we can improve its energy efficiency. Because energy efficiency as an objective or criteria belong to technical aspect, it usually has significant impact on economy and also carbon dioxide emission. That's the reason why we need to we propose in order to achieve carbon neutrality, we need to consider multiple objectives, multiple stakeholders, and also multiple scales, and also multiple type of interaction among different systems. The second aspect, I think that all of us have ever heard a Greek agent, the so-called Midas touch. There's a man with superpower who can turn the waste into gold and also some value-added product. Okay, It's a pity I do not have any superpower, but we can develop some innovative process based on mechanical model and also the data-driven approach to develop innovative process to turn waste into value-added product. And also in the process we have developed, we usually consider how about the economic and also how about the environmental and also social contribution. So we incorporate economic, environmental, and social objectives simultaneously in the process design for carbon neutral production and carbon neutral manufacturing to achieve the so-called BCE economy. B represent bioeconomy, C circular economy, and G represent green economy. Okay, now I'd like to show some of our work in detail. In our work, we have developed a model to achieve carbon neutrality for carbon neutral or sample production or manufacturing in a multi-scale approach from process unit to plants to sites to enterprise by incorporating the concept of circular economy, symbiotic transition, and resource and energy improvement in the process design. Actually, at process level, we combine the firstly we simulate the process based on first principle, then determine the best operating condition to achieve the so-called carbon neutral process. Then the data we have determined, especially the best, the optimal operating condition will be used in the life cycle analysis of product. You may ask me the reason. We have already determined the so-called carbon neutral process. So why we need to attend or promote it to the life cycle perspective? I can give an example. For now, in Hong Kong or in some other cities, we will say that the electronic vertical is sample, it is carbon neutral, and hydrogen for your cell is also carbon neutral. Actually, is it right? Is it correct? Actually not. Why? We need to ask, and for the carbon for your cell vertical, where does the hydrogen come from? If they from biomass gasification or from coal gasification, we can say that it is not actually carbon neutral. Similarly, for the electronic vertical, okay, we would like to ask, where does the electricity come from? In addition, where do the batteries come from? If we consider the manufacturing process for battery, and also the production process for electricity or hydrogen, then it is not carbon neutral. So we will attend process level to life cycle level to analyze whether the whole product is carbon neutral or not from life cycle perspective. Meanwhile, similarly, even it is carbon neutral at the process level and at life cycle level, we can also not guarantee that it is carbon neutral at a supply chain level or at regional level. So it means that a process is carbon neutral or a product is carbon neutral from the perspective of life cycle. We cannot guarantee that, okay, the whole region or the whole country can be carbon neutral. So we also develop some model to achieve carbon neutral industry, carbon neutral city, and even carbon neutral country. Okay, at the process level, we have developed some innovative process by creating some innovation. And for the traditional process, okay, for that, the traditional process with various of emission, especially some greenhouse gases, okay, from that carbon dioxide or some other gases. So we will consider how we can improve its efficiency and also consider how we can use the carbon dioxide simultaneously. This is a traditional process, and we know the efficiency have significant impact on the emission of greenhouse gases. In addition, we will consider how we can use the carbon to achieve carbon neutrality at the process level. So this is so-called design innovative process. In addition, as for the waste, we will consider how to translate it, to convert it into the carbon-free fuel, for instance, the hydrogen, that it can be used in industry. Besides this, okay, firstly, at the first step, we determine the integrated process with almost zero emission. Then we will consider how we can optimize all the process. For instance, this is the process of waste to hydrogen process, including gasification, power generation, and also some other process, for instance, heat recovery, to improve its energy efficiency. Then we develop multiple objective models to optimize the process. We consider the economic objective, environmental objective, technical objective, safety, and some other factors to incorporate the preference and willingness of all the stakeholders in the process to achieve carbon neutrality at the process scale. Then we incorporate to aggregate all the economic, environmental, social, technical, and even political and policy impact into the so-called composite sustainability index. Then we use the composite sustainability index as objective to optimize the whole process to achieve carbon neutrality at the process level. Okay, according to our study, it is helpful to achieve zero emission at the process level. Besides it, we also incorporate to integrate renewable energy with CCUS. CCUS is short for carbon capture, utilization, and storage process to ensure that all the whole manufacturing or production process is 100% carbon neutral and with almost zero waste. And for this kind of new emerging technology, we cannot simulate the process based on first principles. So what should we do? Of course, we can use the big data analytics, deep learning, and machine learning to simulate the process. Here we have also proposed a very simple but very useful method, so-called high-dimensional model representation method, short for HDMR, to represent the process. But that if we don't know the exact mechanism or we don't know the principle of carbon dioxide emission with operating conditions, then we can use this model to describe the relationship between carbon dioxide emission and the operating condition. Then we can optimize the whole process to ensure that it will have the least carbon dioxide emission. At life cycle level, we combine LC, LC, and SLC, namely life cycle assessment, LCC, life cycle costing, SLC, social life cycle assessment, into one to have life cycle sustainability assessment, especially to audit the carbon emission from life cycle perspective. Based on this one, we combine with some operation model, for instance, about the data envelope analysis to investigate the input and output of each process to identify the bottleneck and the hotspot for these three processes. We can use the model to identify the hotspots and the bottleneck. What are the causes? What are the critical causes? What are the leading reasons that cause low energy efficiency or high carbon dioxide emission? So based on this one, for this process, it can help us to identify, to tell the stakeholder, to tell the producer what you should do, what are the corresponding actions you can take to ensure that you can lower or reduce carbon dioxide emission effectively and significantly. So this is what we can do through our model. And based on this one, we can also have life cycle, environmental efficiency, and economic analysis. It can also help us to identify what are the bottlenecks and the economic impact for the energy efficiency, how we can improve the energy efficiency, and where the bottleneck, what are the hotspots, and what we can do Similarly, for environmental impact, carbon dioxide emission, how can we lower the emission of carbon dioxide? And what we can do to reduce the global warming potential. So this is all what we can get directly. Similarly, for economic impact, we all know for some new process, especially some so-called carbon neutral process, they are not cost effective. So based on the life cycle economic analysis, we can also tell the producer and also tell the government what they should do, especially for some financial support, some subsidies, what they can provide to the producer. Okay, for instance, what are about the tipping fees and also some financial supporting to make this process and the product to be cost effective. We are mentioning, okay, we have developed model at the process level to ensure that it is a cross carbon neutral process. We have also mentioned how we can develop the model to ensure that it is a carbon neutral product. In that process life cycle, I call this as point, this as line. Then next step, we should about a plan how we can achieve carbon neutral region, carbon neutral city, carbon neutral industrial park, carbon neutral supply network. So we have combined life cycle thinking with image, with ecological footprint, especially carbon footprint, interval zero, and superstructure to achieve life cycle modeling and to achieve system integration to ensure that the whole city or the whole country, the whole industrial park will be zero carbon emission. Okay, so let me show you some of our work. For now, at this one, we would like to design a carbon neutral supply network for sewage sludge valorization. We would like to convert the sewage sludge into value-added product and also with almost zero emission. This is part of our work. In our work, there's a unique characteristic. We consider different kind of carbon regulation. Okay, different carbon cap and track regulation. How we know that the government policy usually will change. For instance, maybe next year there's a new policy. So how can we make dynamic decision? Especially how can we make good choice and informed decision to achieve carbon neutral supply chain? Okay, this is an example what we have done about sewage sludge valorization supply chain. And based on this one, we would like to achieve carbon neutral city, carbon neutral industrial park, carbon neutral country. We have incorporated the philosophy, the concept of a circular economy and industrial symbiosis into process design to achieve system thinking. For instance, if there are 5 processes, there are 5 systems, okay? The byproduct or the emission, especially the waste of one process, can be used as a feedstock of another process. So this is so-called industrial symbiosis, okay? For instance, the waste of one system or one process, it can be used as feedstock in another city. Similarly, okay, what we want to solve, we would like to achieve carbon neutral manufacturing or carbon neutral production. So the carbon dioxide in the manufacturing process can be used feedstock in another process as a feedstock. It has 2 benefits. It can not only increase the economic benefits, it can also decrease the carbon dioxide emission, then to achieve almost zero emission. Okay, I present all the 3 level framework and model how we can achieve carbon neutrality at the process level and life cycle level and at the industrial level or even at the regional and the national level. So lastly, I would like to share some of my thinking. How can we achieve carbon neutrality in future? This is a very hot spot. I would like to share some of my initial opinion. I think that firstly, I'd like to propose a multi-act framework to achieve carbon neutrality. First, my stakeholder. We must consider the preference and willingness of different stakeholders, including for that investor, government, NGO, user, producer, consumer, customer. Because just like we have mentioned, as for the hydrogen for your cells, okay. As for the user, yes, they are 100% carbon neutral. But if we consider the producer, it's not correct. So if in the process to achieve carbon neutrality, we need to consider different stakeholders, especially they have different type of willingness and preference. The second aspect, we need to consider multiple dimensions. We have mentioned the objective economic, environmental, and social impact. They are not independent, but they are interacted, and they will influence each other. So we must consider economic, environmental, carbon emission. It belongs to environmental impact, but we also need to consider how we can improve different sustainability pillars simultaneously. That we have mentioned, even we can achieve carbon neutral region, we cannot ensure that it is also 100% carbon neutral at the provincial and national level. So we consider multi-level approach to achieve carbon neutrality. That mass scale, process scale, life cycle scale, and supply chain scale, and to investigate the complex and complicated relationship among them. Then fifth, point 5. I think that no matter to achieve a carbon neutral process or carbon neutral city, we need to consider to use different approach. Sometimes they incorporate renewable source, waste drainage, DME, distributed and system, and energy efficiency improvement, CCUS, and some other tools to combine them together to achieve carbon neutrality. Then the last one, we need to consider how interactive solution for different sectors. Carbon neutral at one sector does not mean that it will also be carbon neutral in another sector. Okay, thank you. So.